Hello, guys. Very good morning to everyone. I just want to take your attention for a minute. Just imagine you're in a factory at 3 a.m. Everything is working fine. All the machines, they're on running in their time slots. Nobody is watching you, but yet you're burning a lot of power and the carbon emission is not recorded. But multiply this issue with thousands of industries going on working at this time. So there is a lot of carbon emission, carbon wastage going on. But what if the companies or the factories predict what's happening and plan and autonomously do the calculations so that they can reduce a lot of carbon emission going on? So here, our team, NVBTU, we are here with a solution, the AI-based solution to reduce the carbon emission going on inside the factories. We focus on major three things the main industries are going through, which is the static scheduling, the carbon emission, and the error rates, which are more likely to happen, and this can reduce a lot of carbon emission which is going on inside the factories.
Okay. Let me explain you what is the, is it audible properly? Yeah. Let me explain you what is the market opportunity for our product. First, you could see in 2023, as of the calculation, you could see it was like 38.6 billion. In 2028, it's predicted by the authorized references, it's like 253 billion. It's a huge market. It's almost competing towards the AI. How the AI grows, it grows. Other than that, there is a potential pressures from the governments, like from EU and from US. There is a true treaties which is already done, which is the Paris Agreement, which is done with the 190 countries. They are planning to reduce the global warming to the 2% of Celsius. Other than that, SEC climate rule from US, they are trying to look the carbon emission data as crucial as financial data. It is producing a huge market for us. Even if we provide a small solution to us, it's going to be $1 million company. That's what. Yeah. Just give a small intro about our solution. We are purely from AI, so that we took the solution towards the AI. So we proposed the 3 agent solutions here. As you have, we have a forecasting agent, decision agent, and the executor agent. As of now, most of the industries are just struggling with their manual data and a lot of grunt process going on. So we are just trying to give an intelligence to them, getting their raw data and giving them insights, and then giving them insights to take actions. But we don't take action, but we will give the insights to them to take the action. Yeah.
So let's deep dive into our each agents. So the first one is forecasting agent. The forecasting agent, we could say, is the predictive backbone of CarbonIQ. It usually, we use dual model architecture here. First one, the Prophet for fast and no fuss deployment, and an LSTM model for as a fallback for capturing long-term patterns. So this lets us combine reliability with learning depth. And it ingest rich data from PV systems, load meters, weather APIs, and calendar, like holidays or shift changes, to boost prediction accuracy. And the output includes not just estimates, but also confidence intervals and surplus deltas to guide the downstream decisions. And to keep performance sharp, the agent includes a self-scoring logic, which autoflux model drift and triggers restraining when needed. Usually, when the predictive error exceeds the hypothesis, we can use this self-scoring logic. So the next one is decision agent, which is like the core backbone of CarbonIQ. Usually, how it works, it's usually turns predictions into optimized energy plans. It works by combining forecast, real-time pricing, and carbon intensity into a unified decision space. It usually starts with Data fusion, merging inputs like solar or load forecast, grid tariff, and CO2 signals into a common time-aligned frame. Next, it performs consistent encoding, which is like embedding operational rules, comfort thresholds, and battery limitations directly to the logic. So using this context, the agent runs multi-objective optimization to generate plans that balance cost emissions and comfort. And the output, what is the output from decision agent? A set of actionable strategies that can be executed autonomously and reviewed manually with full reasoning and fallback logic.
Next, we have the executor agent. This is basically the special sauce of our application. We could say it is like the part where the action is getting taken. So we get the decisions from the decision agent, which will either be to reduce HVAC output or run the machine at a different time. And we will have the executor agent execute these commands or escalate this issue to the supervisor. So we will always have human in the loop. And it will also have audits because we need audits for EU compliance. And this is basically a competitor analysis. Our main competitors are Dexma, which do not have forecasting, but our forecasting is 72 hours ahead of time. And we will have ML-based optimizations. And the main part of our application is autonomy. That's what we're trying to achieve with this.
So here we have the business model. So we have 3 pricing strategies like basics, pro, and enterprises. So for the companies which are going to no need of more integrities or more workload, they can go for the basic, and for advanced optimization, they can go for the pro. And we have the targeted customers and optional add-ons. So targeted customers are manufacturing and processing companies, then energy serving companies, and facilities managers of commercial buildings. So at CarbonIQ, we combine strong domain expertise with lean and scalable tech stacks to deliver industrial grade energy intelligence. So first is deep technical expertise. The second one is 100% open source Python stacks. Then the enterprise grade security. So together, this foundation enables us to move fast, deploy flexibilities, and scale confidential across industries. Great changes begin with smart decision, and smart energy is where it starts. Thank you. Thank you.
Thank you for the presentation. There was a lot of technical stuff I think we had trouble following. So I'd like to ask, which of the technical parts of the project have you most thought of and most validated, or is most impressive for you? Like what kind of machine learning, AI, MQTT, Modbus, there are a lot of terms. Which of it was most impressive for you?
Yeah, let me put it in a simple way. Like there is one model which is called LSTM, which will predict the future forecasting, which is so far used in a lot of the industries, even in trading, which is so inaccurate, but where it's doing a great job in LSTM. So we are trying to bring it to here. That's what the main attractive point. That's what we feel. We could do a Gen AI. So far, it's not so accurate. It shouldn't handle that much data so far now. When it's upgraded, great companies are working on it. If they fix it, we will go with it. Otherwise, so far, right now, we have a solution called LSTM. That's what we are trying to do. Yeah.
Thank you very much for your presentation. I have a question regarding the AI models, what you would like to use, because every industrial process is different. And in order to react or predict, you need to know the behavior of the system incomplete. From where do you know the behavior of the system? Is this a training phase, what you also offer then the customers, that they say, look, when I want to use your product, we come for half a year, measure your data, measure the demands of the process, and then you train also this AI in the background? Or do you use models which are existing from your approach?
That's a good question. like we are just focusing on right now on a mid-phased company. They do have a like some mid-size of data. We are not going to train our entire data. There is a one term called ensemble learning, which is like going to work in the back end. It doesn't need that much time to work on it. It will just take your data. It has like previous knowledge. Let's imagine like you are getting a college student and putting it into work. You don't need to teach him from entirely. You just need to teach the thing which he needs to learn in the work. So he knows the basics, but he will learn the integrity, what he knows. That's what it actually works. So it won't take that much time or the thing. It is actually implementable. Yeah.
Thank you very much.
So thank you so much for your presentation. Take me with you. You deal a lot with data, and we have already some challenges with security. So how do you will deal with security of the data?
First of all, we have auditing that is being hashed. So those audits cannot be tampered with. So that adds to the security part. And also we have a special rollback phase. So any instruction that you give, it can be rolled back because you can't be sure how the turnout will be based on the decisions that we make. And that is also a security feature, I would say.
I would like to add a thing. So here, this is completely integrated into the system, so nobody can access from the outside. Only the internal part of the process is being, automated, or everything will be automated, controlled. Yes.
Okay, thank you for the pitch again. We're out of time for questions, and we can move forward with the next team.
Thank you.
Thank you for your time.
So, danke an das Team NWBTU von mir auch nochmal.